Hello everyone, welcome to today's session. Today we are going to talk about what is overfitting in deep learning models. So first I'll be talking about what is overfitting, then I'll give you some tips to overcome overfitting in deep learning models. What is overfitting? If your model performs very well on testing data set, then your model is a good model. Suppose if it doesn't performs well on testing data, but it performs very well on training data set, then your model is said to be overfitting. Suppose your model doesn't perform well on testing as well as on training, then your model is said to be underfitting. So if you have a very less data and you create a model on a very small data set, then your model will be definitely underfitting. If you have a very complex network and you have a very small data set, then your model will try to overfit. It means it learns all the data points and it even learns a noise, and your model will be overfitting. And let me give you another example here. Now this is an example for underfit. So here you see some data points. Now your model just passed through only two data points. All the other data points is not generalized. So here if you see, this is an example for an optimum model because it's tried to fit to the most of the data points. Now here this is an example for overfit. Your model learns all the noise in the data and also it tries to fit all the data points. So this is an example for overfit and this is an example for underfit. We need to create a model which is optimum, which generalizes on the data set. Okay, so I think we have you have a clear understanding of what is underfit and what is overfit. So we don't want underfit, we also don't want overfit. We need to create an optimum model. Now what are the tips to overcome this overfit model? Before I go to the tips, I just want to tell you, when you calculate the accuracy of your model, it is better to follow a KFold cross-validation model to calculate the accuracy of your model. In KFold cross-validation, your entire data set will be divided into K-folds. So here in iteration 1, the last fold will be used for testing, the remaining folds will be used for training. In the next iteration, you can see the n-1 fold is used for testing, the remaining is used for training. In third iteration, you can see n-2 will be used for testing and the remaining is used for training. So like this, every fold will be given the equal priority to be used for testing. So every data fold or every fold will be used for training as well. So if you follow this KFold cross-validation and calculate the accuracy of your model, you will get the correct accuracy of your model. So it's better to follow this technique when you divide your training and testing data set. Now once you get overfitting, so as I told you already, what is overfitting? Overfitting is your accuracy, your training accuracy is very large, but your testing accuracy is very less. So if you get overfitting, now what are the tips to reduce the overfitting? The first tip is you have to increase the size of your data set. So if your data set size is very small, then your model tries to overfit. So how will you increase the size of your data set? You can follow any data augmentation technique. Data augmentation technique is the artificial way of increasing the number of samples by rotating your image or by adding noise to your image or zooming your image, etc. I have given a video on how to do data augmentation. I will give the link of that video in the description box. Kindly go through it. The next step is to reduce the model complexity. Don't create a very complex model by adding more number of neurons. Then your model tries to learn every feature in your data set and your model will become overfitting. So try to create a simple model. Okay, so again, it's not a hard and fast rule. It's not a hard and fast rule. You have to try for various combinations. So your model should be as simple as possible. The third techniques you have to do is early stopping. Let me show you what is early stopping. Now, before I show the early stopping, look at this model. You can see the accuracy of your training data sets is 100%. Okay, and this is the accuracy of testing data set. It's around 85, okay? And you can see the validation loss doesn't decrease, instead it increase. You can see the loss is increasing. While the loss of training decreases and reaches very minimum value, but the validation loss increases. So this is a perfect example of overfitting. So to reduce the overfitting, as I told you, the one of the tip is to use early stopping. Now here you can see I have used early stopping. So here you have to tell, you should not train your model too much. Okay, so when you see the validation loss does not decrease, you can stop training. So if you train too much, your model will start learning too much. So here in Keras, you have early stopping. So here you can see which value you have to monitor. You have to monitor the validation loss. So if your validation loss does not decrease, instead it increase, then you can stop training your model. So in model.fit, you can give callbacks is equal to ES. So this will stop your model in the optimum point. Okay, it will not train your model too much. So this is one tip to reduce overfitting. The next tip to reduce overfitting is to use L1 and L2 regularization. Now this regularization will help you to penalize the weight of the matrix. As the model grows on, the weights will keep on increasing as it learns. The weight keeps on increasing, and that's why the model results in overfitting. So this regularization will help to penalize the weights of the matrix. So now you can see in this example, in any of these dense layers, you can add the regularization. So here we are using L2 regularization. Mostly we will prefer L2 instead of L1. And you can see a lambda value is given here. So this is to penalize your weights. Okay. So now we are preferring L2 instead of L1 regularity. Mostly we will prefer L2. So here you can see the alpha value is 0.01. Again, which value is best? You have to use grid search to find out which is the optimum alpha value. So you can add this regularization to any of these dense layers to penalize the weights. So this will be one technique to reduce overfitting. The last technique to reduce overfitting is to use dropout layer. The dropout layer also uses the same concept of regularization. So dropout layer also will drop some neurons. So since if you had more number of neurons in your model, it tries to learn all the features. Sometimes it also learns noise or some wrong data in the data set. So you will drop out some neurons in your dense layers. So how to use this dropout layer is, let me show you an example. So if you see in this example, in this model, you can see a dropout layer is added in between the dense layers. Okay. So by adding this dropout layers, some neurons and the weights of the neurons will be dropped out. So by adding the dropout layer also, you can reduce overfitting. Now here you have to tell how much probability of neurons has to be dropped out. Okay. So this also will reduce overfitting to some extent. Okay, so let's revise the tips that we have seen. The first tip is you should need a very large data set. So here you can see I have used an augmentation technique to increase a number of samples. See, actually I have 8,000 images. By adding augmenter, I can increase the number of samples. So here you can see I'm increasing the number of samples to 12,000. So you can increase the number of samples. I have separate video for augmentation. Please go through that link. That is the first tip. The second tip that you have to do is you have to reduce the model complexity. So you have to make sure your model is as simple as possible. Don't add so many layers to your model and make a very complex model. The model will try to overfit. The third tip is you have to use early stop. So you should not train your model too much. Sometimes some people will train their model to 300 epochs, 500 epochs. So if you see the validation loss doesn't decrease, then you have to stop training your model. So you can use early stop to find out the optimum point where you have to stop training. The fourth technique you have to use is you have to use L1 and L2 regularization. So you can add this regularization to any one of the dense layers. So mostly we will prefer L2 regularization. It just penalizes your weight matrix. Okay, the last technique is to use the dropout layers. So when you create a model, you have to add dropout layers in between. Tell how many percentage of neurons has to be dropped. By adding the dropout layers, you can reduce overfitting. Thanks for listening. Hope you understood the concept of overfitting. We will see in another session. Stay tuned for more videos. Thank you for listening.